Hey, welcome to my video about phase diagrams and using them to investigate things like melting point and boiling point. So we said in an earlier video that there's such a thing called the normal melting point and the normal boiling point. And if you remember, the normal referred to the fact that that's when the pressure of the air of the surroundings is 1 atmosphere. So on a normal day right here on the Earth, on average, it's about 1 atmosphere. So how can we measure something like the melting point? Well, imagine now that you are melting a substance. And if you're melting a substance and you're at 1 atmosphere of pressure, then you're going to heat up the substance. And so essentially you're walking to the right on this diagram. And so if we imagine this phase diagram as essentially being a map, as we walk to the right, we're going to see what happens if we're a little ant on here, right? We're solidly in the solid phase, no pun intended. And as we get to a point right here, the liquid phase is equally as stable as the solid phase, and so this is referred to as the melting point. And as we transition to the right, then we can see that we have melted and we have completely formed liquid. And as we keep increasing the temperature, we can see that the liquid phase is still the stable form. And then we reach a point right here where the gas phase is now equally stable, and this is the boiling point. And of course, as we raise the temperature above the boiling point, the substance is completely boiled and turned into a vapor. And so we can draw here the melting point and the boiling point. And remember, these are actually the normal melting points and the normal boiling points. We can see what will happen to something like water as we increase the pressure. So if we go to a higher pressure, so we have a pressure cooker, we can see that the melting point is actually going to be, it's going to be lowered, right? So the normal melting point is right here. And now, as we have increased the pressure, the melting point has actually moved to the left to a lower temperature. And as we go ahead and we continue to raise the temperature, we can see we walk through the liquid phase, and then we reach a point right here where we transition from the liquid to the gas phase. And so that is the boiling point. And so we can see the boiling point before used to be right here. And now, because we have increased the pressure, the temperature that it's required to boil at has actually gone up by quite a large amount. We'll see that increasing the pressure will lower the melting point by a very small amount for most substances, but will raise the boiling point by an extremely large amount for most substances. So you get a much bigger difference in boiling point change than melting point change. And I didn't draw the line very well here, so the phase diagram I should probably go on past there, otherwise it looks like we were at that supercritical point there. So you can see then we can use the phase diagram to predict what will happen as we change the pressure. In fact, as we go from higher pressure to lower pressure, we can see that that would mean that the melting points would lower. In fact, if we maybe start here, we can see, oh, I said the wrong thing, didn't I? The melting point actually increases, so it is further to the right. So it's going to have a higher melting point here at lower pressures. We can see, though, that at lower pressures, the boiling point definitely decreases. So as we lower the pressure, we can more easily boil a substance. And so that's just kind of one of those standard tricks we use in the lab all the time. So if we want to easily boil a liquid, what we have to do is actually hook it up to a vacuum pump, lower the pressure, and it boils much more easily. One of the interesting things is, actually, if we go to a very low pressure, we actually can go directly from a solid to a gas. So actually it no longer melts anymore. We no longer have a liquid phase, and we just are doing, do you remember what that's called? Going from solid to gas? Yeah, that's sublimation. So we just have a sublimation point right here. So we actually lack the presence of a liquid. And depending on the substance, right, depending on its phase diagram, something like carbon dioxide at 1 atmosphere of pressure, it actually doesn't have a stable liquid phase. You immediately just cross from a solid to a gas phase. So that's why it's called dry ice, because it just simply doesn't melt.